Makita po, ma'am.
Yes, Manessa.
Okay, mag-start na, ma'am.
Laika.
Okay. So, good morning. Good morning, ma'am. Good morning, everyone. We are going to report the activity for measuring volume. So, the precise measurement of volume is as important to many analytical methods as is the precise measurement of mass. So, for the objectives, first to identify the different types of apparatus in measuring volume. Second, to identify the type of calibration and function of each apparatus. And last, to understand the process of calibration. So for the first activity, using a pipette supply the needed information for the following types of pipette. So here are the types of apparatus in measuring volume. So first is the volumetric. Its type of i-explain ko muna yung to deliver and to contain sa type of calibration. So yung to deliver is a type of calibration that will dispense the exact volume na gina-indicate. And ang small amount ato is should not be blown out. And for the contain, to hold or contain particular volume but does not dispense exact volume. So for the volumetric, the type of calibration is to deliver fixed volume of liquid, and it has a capacity of 100 ml, and its type of drainage is a free drainage. Second is the more. Its type of calibration also is to deliver, its function is to deliver small portions of liquid with the capacity of 10 ml, and it is to drain to lower calibration. So the serological pipette is to deliver that its function is to transfer milliliter volumes of liquid with the capacity of 50 ml, and its type of drainage is to blow. So serological pipette is it can also be to contain. It is also be used in containing volume. To contain quantity of liquid corresponds to the capacity, which is the 50 ml, and its type of drainage is to blow out. Fifth is the Ostwald Follin to deliver a fixed volume with the capacity of 0.25 ml, and its type of drainage is to blow out. The lambda also has two type of calibration. First is to deliver a fixed volume with the capacity of 0.001 to 2 ml, and it has the type of drainage is to blow out. The second type of calibration for lambda is to contain a fixed volume, also the same capacity of 0.001 to 2 ml, and its type of drainage is to wash out with suitable solvent. So last is the Eppendorf. Its type of calibration is to deliver variable or fixed volume with the capacity of 0.001 to 1 ml, and its type of drainage is tip emptied by air displacement. So those are the apparatus used in measuring volume with its type of calibration. So for the next part, Jamie, go.
So hello for so cleaning a pipette. So how do we clean a pipette? So first step is we use a rubber bulb to draw detergent to a level 2 to 3 centimeters above the calibration mark of the pipette, and then we drain this solution and then rinse the pipette with several portions of tap water. And then we check if there's breaks, if there's may mga basag. Then after that, if it's necessary, we repeat this cycle 2 to 3 times para mas make sure like walay mga problems, walay mga buak and ano. Then finally, we fill the pipette with distilled water to perhaps one third of its capacity and carefully rotate it so that the entire surface is wetted. So why do we need to clean a pipette? Uh, a pipette should be cleaned regularly to for us to guarantee na there's no contamination, then there's no contamination and all, and para po sa ato ang safety. And the liquids in the lab can be infectious, like toxic, harmful, and if like magka-aksidenta sa lab, like mahulog asa taga na mayabuan og liquids and magyabo, so magka-infectious gid da, and kailangan nato na siya i-clean og water para mawala din tong kay dili kay siya mag-trigger pa. Then most of these liquids are transferred using a pipette, so we need to regularly clean a pipette tube. So next is measuring an aliquot. Uh, Use a rubber valve to draw a small volume of the liquid to be sampled into the pipette and truly wet the entire surface, and then repeat at least two additional portions. So this procedure is aliquot means contained an exact number of times in something else. We can use aliquot measurement when drug requires a degree of precision in measurement that is beyond the capability of the available measuring devices. It means a part of a chemical or medicine. Besides functioning as a technique used to separate a larger sample into smaller parts, aliquot plays a very important role in measuring the validity of products. Experts
Na robot na. Jamie? Jamie? Nawala? Nawala siya?
Nalobat na si Jamie, ma'am.
Pasalo sa sa groupmates.
Wala na si Jamie. Sige, next na lang, Mon. Para sa procedure, padayon na lang. So, So, in measuring the aliquot, next is to carefully fill the pipette to a level somewhat above the graduation mark. Quickly replace the bulb with the forefinger to arrest the outflow of the liquid and make certain there are no bubbles in the bulk of the liquid or foam at the surface. Tilt the pipette slightly from the vertical and wipe the exterior free of adhering liquid. Touch the tip of the pipette to the wall of a glass vessel and slowly allow the liquid level to drop by partially releasing the forefinger. Halt finger flow as the bottom of the meniscus coincides exactly with the graduation mark. Then place the pipette tip well within the receiving vessel and allow the liquid to drain. When free flow ceases, rest the tip against the inner wall of the receiver for a full 10 seconds. And finally, withdraw the pipette with a rotating motion to remove any liquid adhering to the tip. The small volume remaining inside the tip of a volumetric pipette should not be blown or rinsed into the receiving vessel. Mo next.
So next is using a barrette. So first, the cleaning barrette. So thoroughly clean the tube of the barrette with detergent and a long brush. Rinse thoroughly with tap water and then with distilled water. Inspect for water breaks. If necessary, repeat the treatment. So for the filling of barrette, make certain that the stopcock is closed. Add 5 to 10 ml of the solution to be dispensed and carefully rotate the burette to wet the interior completely. So the purpose of this procedure is burette is designed to make precise volume measurement. So if you rinse the burette with the solution, then any amounts of liquid remaining inside are the same as the solution to be used to fill the burette. So it will not change the concentration of the solution in any way. So the next step is allow the liquid to drain through the tip. Repeat this procedure at least 2 or more times. Next, fill the burette well above the zero mark. Free the tip of air bubbles by rapidly rotating the stopcock and permitting small quantities of the titrant to pass. Finally, lower the level of the liquid just to or somewhat below the zero mark. So lastly, allow for drainage approximately 1 minute and then record the initial volume reading. Estimate to the nearest 0.01 milliliters. So that's how you fill the bird. So we have the initial reading based on that picture below 0.01 uh, ml. For the final reading, 17.3 ml. So we computed for the volume delivered. So just subtracted. So the volume delivered is 17.2 milliliters. ml.
Next, using a volumetric flask. So, ang volumetric flask ay ginagamit siya to prepare solution. So, clean the volumetric flask through washing the detergent with detergent and should be rinsed thoroughly. Direct preparation of a standard solution requires introduction to mass solute to a volumetric flask. Weigh the solid into a beaker, add solvent, heat to dissolve, and allow the solution to cool to room temperature. So beaker yung gamitin pang sukat. Transfer the solution quantitatively to the volumetric flask by inserting a funnel and using a stirring rod to direct the flow of the liquid from the beaker into the funnel. Rinse the stirring rod and interior of the beaker with distilled water down into the flask and repeat at least 2 more times. After being transferred, fill Fill the flask about half full and swirl the contents to hasten solution. Once it dissolves, bring the liquid level almost to the mark and allow time for drainage. Using medicine dropper to add to make sure use use medicine dropper to add to make sure to make such final decisions as necessary. Transfer the contents to a storage bottle.
So next is discuss the process of calibrating the following instruments. So based lang to sa aming research. So yeah. So number 1 is pipette. Determine the empty mass of the stoppered receiver to the nearest milligram. Transfer a portion of temperature equilibrated water to the receiver with the pipette. Weigh the receiver and its contents and calculate the mass of water delivered from the difference in these masses. Calculate the volume delivered and repeat the calibration several times. Calculate the mean volume delivered and its standard deviation. So I can't explain it pa because wala man ta nag-actual and hindi ko din po alam if tama yung mga nasa internet kasi paiba-iba silang lahat. So yeah. Next is the burette. Touch the tip of the burette to the side of a beaker to remove the drop hanging from the tip. After about a minute, to allow for drainage, make an initial reading of the meniscus estimating the volume to the nearest 0.01 ml. Record the initial reading and allow the burette to stand for 5 minutes and recheck the reading. The last one is the volumetric flask. Weigh the clean and dry flask to the nearest milligram, then fill to the mark with the equilibrated water and reweigh, and calculate the volume contained. So the last one is the conclusion. So in this activity, we were able to identify the different kinds of apparatus used in measuring volume. Also, its type of calibration was identified and got to understand the process of calibrating the different apparatuses. So that's all. Thank you for listening.
Okay, so thank you for that report. Before I will wrap up the activity number 4, do you have questions sa reporters class? Meron kayong questions sa mga reporters natin? Wala? So again, i-wrap up ko ang ating activity number 4 ha. Para you will know if your answers are correct. And para ano siya, sa exam, ang inyuhang mahatag na answer sa mga questions will be correct also. So activity 4, do not forget, we have measuring volume. We are done with the mass. This time, volume na po dato ang istoryahan. So most likely, this is for our liquids. So we have units of concentrations class. Most likely, we will be using the liter and then the milliliter. So as you can see in your activity, liter is defined as 1 cubic decimeter. This is our international standard for volume. However, if it is inconvenient to use the liter because we will just measuring a small amount of the liquid, then we can use the milliliter. So do not forget that milliliter is 1,000 of a liter. That's our conversion factor. Sa isa ka liter class, we have 1,000 ml. Now, to measure the volume of our liquids, we can use equipment like the pipette, the burette, and the volumetric flask. Again, these are our apparatus in the lab, or apparatuses in the lab that are accurate para ma-measure natin ang ating liquid. Though graduated cylinder is okay, however, these three, they are more accurate than the graduated cylinder. And then paulit-ulit na ko ginaingon, please do not ever use the Erlenmeyer flask and the beaker when you want to measure the liquid. Those two are just designed to contain our liquid. So without the measurement. So do not forget, when you say pipette, we use the pipette to transfer accurately known volumes of our liquid from one container to another. And then when you say burette naman, ang burette natin class is a very long tube na calibrated. When you say calibrated, meron siyang mga graduation mark for the measurement of the volume. And at the end of the tube, there is a stopcock na ginagamit siya to control the flow of the liquid. And then the last one, we have the volumetric flask. This is a flask with a long neck, and it only has one graduation mark sa neck niya. Meaning, ang isa ka volumetric flask is designed for one measurement only. If it says 100 ml, therefore that volumetric flask is used to measure exactly 100 ml volume of the liquid. So again, ito yung ating mga volumetric na mga equipment. Now let's start on using the pipette. So the first part sa inyuhang activity is to answer the table. We have different types of pipette. You have to supply the type of their calibration. Either they are used to deliver or to contain. And also their function, the available capacity in ml, and the type of drainage. So the first one there, you have the volumetric pipette. So the volumetric pipette class is used to deliver, and gina-deliver niya is a fixed volume, okay? Ginagamit siya to deliver fixed volume of liquid. So we have volumetric pipette from 1 ml to 200 ml. And then sa drainage naman, it's free. You just have to let the fluid or the liquid flow. So this is how a volumetric pipette looks like. So you can identify them sa presence ng valve. Parang ano, ay, bulb pala. Parang bulb siya. And then you only have one graduation there. So when you say 100, nakasulat dyan 100, this is designed to deliver fixed volume that is 100 ml. Again, this is how a volumetric pipette looks like. We have different volume na pwede niya ma-deliver. Now, how about the more pipette? The more pipette is also used to deliver, but this time variable volume. So you will see later bakit variable volume. Now we have more pipette na from 1 ml to 25 ml and ginagamit siya to lower calibration line, yung drainage niya. So this is how a more pipette looks like. Meron siyang calibration like from 0 to 1 to 10 ml here. So this is a 10 ml more pipette and it can deliver variable volume. So if you want to deliver 2 ml, so you just have to let the liquid flow until lower the calibration line. So that's 2 ml. So diri lang po ka banda mag-stop. Okay? So again, ang drainage is to lower the calibration line. So depende kasi variable volume ang dinideliver when it comes to the more pipette. Unlike the volumetric pipette na fixed volume lang jud. Pag maingon kag 30 ml na volumetric pipette, then 30 ml until the calibration line. This time, you can fill the more pipette up to 10 ml but you can deliver any volume. Any volume, pwedeng 7 ml. You just have to let the liquid flow and then stop sa desired na graduation mark or desired volume. Okay? Questions about the volumetric and the more pipette? So let's move on to the serological pipette. Now we have two types of serological pipette. Both of the pipettes are used to deliver. And to be exact, ano siya? Ginagamit sila to deliver variable volume also, just like the more pipette. And then we have also serological pipettes that can deliver 0.1 and na ay hangtod 10 ml na serological pipette. Now, asa sila nagkaiba? We have serological pipette that is a blowout pipette, meaning hangtod sa last drop, you have to blow out everything. And then we also have serological pipette na gina-drain nato siya until the lower calibration line. So how does the serological pipette looks like? So this is the serological pipette. Okay, so just like the more pipette, you can see there mga graduation marks. That is why it can deliver variable amounts or variable volumes of our liquid. Now, what's the difference between a serological pipette and a more pipette? Actually, we have serological pipette class nga hangtod sa end na sila'y calibration. Si more pipette man good, as you can see, malayo pa siya sa end yung mga graduation marks. Ang serological pipette, just like this one, malapit na siya sa end yung kanyang end ng graduation mark. Okay, so this again is a serological pipette. We have a blown out pipette na serological, and then we have another one na to the calibration line. Okay, so like when you want to deliver 4 ml, so pababa ka hanggang you'll get the 4 ml. Depende sa mini-measure mo or dinideliver mo na volume. Okay, again, that is serological pipette. Now, number 5, we have the Ostwald-Follin pipette. This is also used to deliver, but this time it's the delivery of the fixed volume, just like the volumetric pipette. And then we have Ostwald-Follin pipette na ang capacity is 0.5 ml, and then meron din tayong medyo malaki, we have until 10 ml. Now, just like katong isa ka type sa serological pipette, Ostwald-Follin pipette is also a blowout last drop pipette na type of drainage. So this one is the Ostwald-Follin pipette class. Okay? Wait lang. This one is the Ostwald-Follin pipette. Paano siya nag-differ sa itong isa volumetric pipette. Take note that the volumetric pipette, ang valve niya na diri medyo sa taas. Kani diri siya more likely sa end, but it also has one calibration. So if this one is for 10 ml, then hangtod 10 ml lang jud ang iyahang gina-measure. Now, para asa si Ostwald-Follin pipette class. Ang Ostwald-Follin pipette is also known as the blood pipette. Kasi most of the time, this is the pipette that we use when we want to deliver volumes of blood. And aside sa blood, ginagamit din si Ostwald-Follin pipette to deliver class kanang mga viscous na mga fluids. Okay, when you say viscous, kay kanang sa Bisaya ang viscous. Kanang malapot na mga fluids. So dili siya free flowing na mga fluid. Paglapot gani class, ang ginagamit nato Ostwald-Follin. So tama na siya, George, na this one is a pipette used in blood chemistry kasi mao ni siya ang pipette designed to accommodate blood and other viscous na mga fluid. So I hope that is clear. And then we have another type of pipette. We have two actually. We have the lambda and the the lambda. Duha sila kabuok. Ang ilahang difference, the other one is used to contain certain amount of liquid, while the other one is used for the delivery of a fixed volume of liquid. Okay? The other one is to contain, the other one is to deliver. However, take note that we have fixed volume for the lambda. Class, basta fixed volume gani ang gina-deliver sa ato ang pipette. Always remember na isa lang na iyahang graduation mark. Ang guhit niya, isa lang pag fixed volume. Pero pag variable volume, mo na siya atong pipette na daghan og graduation mark. So, ang to contain na lambda pipette is, ang type of drainage niya is gina-wash out siya with suitable solvent. As in, ginahurot siya but you have to use a suitable solvent para mahurot ang sulod sa imuhang pipette. While the other one, the lambda na used to deliver a fixed volume, is a blown out pipette. Okay? So this is how it looks like, the lambda pipette. This is actually a small one. Ang atong mga lambda pipettes are actually used to transfer very small volumes of liquid even down to 1 microliter. So again, small volume of liquid, basta lambda pipette. And then the last one, the Eppendorf. The Eppendorf pipette is used to deliver fixed, pwede siyang fixed volume, pwede po siya variable volume, and gina-empty siya by air displacement. So, actually, the Eppendorf is also known as the micropipette. Okay, so this is how it looks like, the micropipette. So, di ba, when you want to drain the liquid from the micropipette, you have to push this button here, and then another push pa, mo na to siya ang air displacement. So the air will just push the remaining amount of liquid na naa sa Eppendorf para mahurot siya tanan. So blown out gihapon but using the air para mag-get rid ang liquid sa Eppendorf pipette. So this type of pipette is also used to measure small amount of liquid. Actually, may tip pa ni siya. So wala lang siya sa picture, but kani sila ginadugtungan ni siya og tip dinhi, and dito nato siya makuha ang atuang gina-measure na liquid. Okay, so those are the types of our pipette. So do you have questions, class? From the volumetric up to the Eppendorf na pipette. Wala. So let us see. Again, let us identify the different types of pipette. So do not forget, this is our more pipette here. Take note of the different calibrations because this is used to deliver variable amounts of liquid. And then this one is the volumetric pipette. As you can see, you have the bulb here and one calibration only. So this is used to deliver fixed volume of liquid. And then this one class is the serological pipette. Okay? So ano po siya, since it has a lot of graduation mark, then it is used to deliver variable volumes of liquid also. And then the Ostwald-Follin pipette is our blood pipette na ginagamit for blood chemistry and to deliver other fluids pero kanang viscous na mga fluid lapot sa ano pa sa Tagalog. And then what do you call this pipette? Wala gisulat ang pangalan. Say tawag ani gani. And then kaning last.
Eppendorf, ma'am.
Okay, this one kaning blue is the Eppendorf pipette. So this is also known as the micropipette. Gina-connect siya sa tip like this one. And the last one, tama na siya like the last one, kani siya, is the lambda pipette. So just like the Eppendorf, the lambda pipette is also used to measure small amount of liquid. So even microliter. Okay, I hope ma-identify na ninyo ang different types of pipette nato. Okay? Can ask question anytime, ha? So when we clean the pipette, I will not dwell sa ani discussion kasi na-discuss ko ni siya when we had our pre-lab discussion. I have also given you the link for the video kung paano i-clean ato ang pipette. So you can review anytime the the procedure on how to clean our pipette. Okay? And then the measuring of the aliquot, sorry. Ang ako ang gibutang lang diri nga procedure kay katong first one kasi may question dito, you have to explain why are we doing this procedure. So ang procedure na to is this one, yung use a rubber bulb to draw a small volume of the liquid to be sampled into the pipette. And diba, it thoroughly wet the entire surface. And then repeat with at least 2 additional portions. So mani siya tong first part in using the pipette wherein we will draw a small volume of our liquid to be sampled. And then diba, i-tilt nato ang atuang pipette and then i-roll until all the interior surface of the pipette will be wetted with a solution. Now, bakit natin ito ginagawa? Yun yung dapat yung answeran sa question na explain why are we going to do this procedure. But take note of this, by rinsing the pipette with a solution to be used, you are making sure na yung concentration of the solution inside will be exactly what you expect it to be. So this one is actually a calibration na process. I-calibrate na to ang atuang pipette na kung whatever is the concentration of the solution na ginagamit, maupod ang concentration inside kasi nakalibrate ang atuang pipette to carry that certain solution. Also, kasi kapag hindi mo ito gagawin, if you don't rinse your pipette with a solution and then na ay mga water inside na nabilin during the cleaning process, the solution you will dispense will be more dilute than it should be. Okay? Kaya katong mga water nga naa sa inside sa pipette will be incorporated to the solution and that will make your concentration lesser compared to the original one. So before really going to measure a volume of the solution, you have to calibrate it first. You have to make sure that all the inside walls of the pipette is ang solution mismo with the certain concentration ang present. Wala na yung water, nawala na ang water para dili siya maka-affect sa concentration. So that is the reason why we do this all the time. After cleaning, before really using the pipette to measure the solution, we have to acclimatize it. The word is called acclimatize, acclimatization. Okay? So that will be the answer for the first part. Now, using a burette, please also take note of the videos, the links in your activities. I have provided there how do we clean our burette and how do we fill our burette. Now, doon sa filling na part, we also have a question, why do we need to rinse our burette with a solution to be used? Actually, it has the same purpose with that of the pipette. So your answer will be for acclimatization also, so that the concentration of the solution is na-acclimatize siya in the walls inside the burette, and if there are remaining water, ma-wash out to siya and it will not be included in the solution. Hindi na siya maka-affect sa concentration. So the same explanation for both pipette and burette. Now, parang hindi ata ito nasali sa report or nasali ba? The initial reading and the final reading. So let's see if parehas taog answer, class. Initial reading, remember this is a clear solution, so lower meniscus. So the lower meniscus is right sitting above, sitting in the graduation mark sa 0. Therefore, the initial reading here is 0 ml. Now, for the final reading, so take note of the meniscus. This is take note, diri sa to sa 18 ha, natay 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Bale, this one is 0.1, 0.2, 0.3 hangtod sa 0.9. So kung gikan siya sa 17, we have 17.1, 17.2, and then the lower meniscus is naa sa 17.3. Therefore, the final reading here is 17.3. So, di ba gihatag nako sa inyo ha ang atuang formula sa pag-compute sa volume na na-deliver. So, final reading minus the initial reading, that is the volume being delivered by our burette. So, 17.3 minus 0 is 17.3. May I know if we have the same answer sa inyong gipasa na activity? 17
Ma'am,
point. Yes, Eden.
okay lang kung 0.01 ang initial reading, ma'am.
Agi 0.01 ninyo. Is this sitting sa
Yes, ma'am.
0.01? 1, 2, 3, 4, 5, 6, 7, 8, 9. Agi 0.01 ninyo siya. It's okay. Sige, sige, sige. Okay lang, okay lang. 0.01. Pero, tanawan ninyo hang lower meniscus kung asa jud siya nag-sit, asa jud siya ni patong sa graduation mark. So actually, tong gihimo nila, I was not the one who made the experiment. Actually, the teacher sa section A ang nag-perform ani na experiment kay wala ko naka-adto sa school ani that time. So ilahang ano jud gipapatong jud nila sa 0 ang initial reading. Na that's okay. So, ang inyong volume delivered is 17.2. Tama?
Yes, ma'am, 29.
Say 29.
17 po, ano ma'am, 17.29.
17.29. Okay, sige na. No problem, no problem with that. Sige. Questions, class, about the use of the burette and paano siya i-read? Wala. Okay, so how about using our volumetric flask? So this is how a volumetric flask looks like. It's like a triangular shape sa baba and meron siyang long neck. And dira sa neck, you can see the graduation mark. So isa lang na iyang graduation mark class. So for example, kanang 1,000, kanang 1,000 ml. So this is designed to be used if you want to make a solution na 1,000 ml. Okay? So ginagamit ang atuang volumetric flask to contain. Okay? Dili siya parehas sa burette and sa pipette na pwede sila to deliver. Kani this one is to contain if we want to make solutions. So pareha sa application nato sa ato ang gina-compute sa lecture, mga different concentration. So kung gusto ka mubuhat og 1 molar na 1,000 ml na solution, then you will be going to use the volumetric flask para maka-measure jud kag exact 1,000 ml. Okay? So isulod nimo imuhang, like for example, powder. Isulod nimo imong powder dinhi, and then you will just add the solvent hangtod sa calibration mark, and then ipa-dissolve na nimo siya dinha. Okay? Again, the videos for the how do we use the volumetric flask is already supplied in your activity. Now, we will be talking about the calibration, but before that, let's have CR break first, class. Kajut lang jud. I'll be back after the CR break. Okay, so let's start with the calibration of a volumetric pipette. And this is how you do the calibration. First, you have to determine the empty mass of the stoppered receiver to the nearest milligram. So, di ba pipette, di ba pag tina-transfer natin ang pipette class, we have a receiver. Pwede siyang beaker, pwede siyang Erlenmeyer flask. So, whatever the receiver is, you have to weigh it, the empty mass plus the stopper in the to the nearest milligram. I-weigh natin siya. And then, transfer a portion of yan siya. Let me correct that. That's of, ha. Can I annotate? Yeah, I can. So this one, transfer a portion of temperature calibrated water to the receiver with the pipette. So kailangan meron tayong water. Yun yung ating i-measure using the pipette, but you have to take note that it should be temperature calibrated. Okay? So sa class, sa pipette, so if this is how a pipette looks like, may calibration siya dyan, actually sa taas nakalagay kung ano dapat yung kanyang temperature. Okay? So for example, ang nakalagay dyan na temperature ng iyong dapat i-measure na volume is 20 degrees Celsius, you have to make sure na ang water na i-measure mo using the calibration is 20 degrees Celsius. Okay? So again, transfer a portion of temperature calibrated water to the receiver using a pipette. And then, after nimo ma-transfer from the pipette to the receiver, you weigh the receiver again and its content. So, kagaina, ang first nato nga gi-weigh is the receiver only plus the stopper. And then, pag-transfer sa liquid or sa water dito sa, using the pipette, i-weigh na to ulit ang receiver. So this time it's the receiver plus the stopper plus the water na. So we have two masses na. Receiver plus stopper plus water. And then we have to calculate the mass of the water delivered from the difference in the masses. So para makuha nato ang mass sa water na na-deliver using the pipette, i-minus lang nato ni siya. So if this is weight number 1, this is weight number 2. So ang atuang formula ani is weight number 2 minus weight number 1. That is already the mass of our water. So calculate the volume delivered with the aid of the table on the next slide. So meron tayong table on the next slide na gagamitin natin to compute for the exact volume being delivered by the pipette. And then we have to repeat this step several times. So mo ni siya ang let me delete the writings has a screen. So mo ni siya ang ato ang reference table. Class, no need to memorize everything ha. Wala ta mo gina-require mag-memorize ani. During the quiz or the exam, you may use this as reference. Pwede ninyo tanawon ang table during the computation. Mabuang taan ni memorize. Kung ipa-memorize na ko ni sa inyo ha. So, okay. So, this is the table. Volume occupied by, wait lang. Okay, by 1 gram of water weighed in air against stainless steel weights. So, for example, class, kung giweigh na to siya at 25 degrees Celsius ang water, mao ni siya supposedly ang iyahang volume. Again, kung giweigh ang water at 25 degrees Celsius, supposedly mao ni ang iyahang volume, 1.0040. Pero kung 20 degrees Celsius, it's 1.0037 ang iyahang corrected volume. So tagaan ta mo og example. Okay? Again, tagaan ta mo og example. Mo ni atong formula. Volume delivered is equal to weight of the water times volume at temperature. So example sa pag-calibrate. Naakay 25 ml na pipette and nag-deliver siya og 24.976 grams. Using the procedure ako ang giingon kagaina ha, na i-weigh una ang receiver plus the stopper, tapos magkuha ka og desired volume sa using the pipette. Example, 25 ml ang pipette nimo, gitransfer nimo ta siya sa receiver, and then di-weigh nimo ulit. And then to get the mass of the water, i-minus lang nimo ang weight of the container plus the stopper plus the water minus the weight of the container plus the stopper. So for example, mauni ang nakuha na weight sa ato ang water using the pipette. So again, 25 ml pipette delivers 24.976 grams of water weighed against stainless steel mass. This is using the analytical balance at 25 degrees Celsius. So use the data atong table kagaina in the previous slide to calculate the volume delivered by this pipette at 25 degrees Celsius and 20 degrees Celsius. So unsaon siya paggamit class? Again, the formula para makuha nato ang volume na na-deliver. Weight of the water, mo ni siya ang nakuha nato, 24.976 grams. Now, first let's have a 25 degrees Celsius. So balik ta sa table, this is the temperature. Pangitaon nato si 25 degrees Celsius. So this is 25 degrees Celsius and supposedly the volume sa water na makuha nato at 25 degrees Celsius is 1.0040. So mo ni atong gamiton sa computation. So 24.976 grams times mo ni siya 1,040 ml supposedly ang per gram nga makuha sa pipette at 25 degrees Celsius. So i-correct nato ang volume na na-deliver. So i-multiply lang nimo na siya class. Pag multiply, you will get 25.08 ml. So ang corrected volume ato, ang nakuha jud sa 25 ml na pipette is 25.08 ml. Mao ni siya ang kanang exact na volume. Kasi 'di ba pag volumetric pipette class, isa lang man na ang iyahang. This is how it looks like, 'di ba? Naa siya bulb, di ko mag-drawing, but anyway, naa siya bulb. And then isa lang ang iyahang calibration, 'di ba? So pag maingon siya 25 ml, 25 ml lang jud na ang iyahang i-measure. However, naaman goy calibration ng atong mga pipette na dapat kung nakabutang din ha 20 degrees Celsius, dapat ang imuha pong i-measure na volume na or solution 20 degrees Celsius po diyahang temperature, pero dili man na siya nga na ang case all the time. That is why we need to correct the measured volume. So kani siya, ang 25 ml na pipette at 25 degrees Celsius, ang total jud na volume na iyahang na dispense is 25.08 ml. Now, kung gusto nimo mabalaan, paano kaya kung ang imuhang liquid na i-measure is 20 degrees Celsius? So diri balik ka dito sa table, class. So ang original man jud nga weight sa steel is ang temperature is 25 degrees Celsius mo na atong gigamit. At 25 degrees Celsius kagaina 1.0040. Pero kung 20 degrees Celsius kani atong gamiton 1.0037. So nganong diri gihapon atong gikuha, nganong diri sa 20? Kasi ang steel mass nato is at 25 degrees Celsius. So mao ni ang ato ang reference. Okay? So muna at 20 degrees Celsius, we will use this corrected na volume. So the same thing, the weight of the water, i-multiply nimo ang corrected na volume. So at 20 degrees Celsius, actually, ang total volume na iyahang na dispense is multiply lang ni silang duha, you will get 27.07 ml. So that's how you calibrate your pipette. If we have differences in the kanang recommended na temperature and then sa temperature nimo nga temperature sa solution nga imong gi measure. Okay, wala na ko ginapa-memorize ang table ha. Pag magpa-compute ko ani sa inyo ha, you can look at the table anytime. Questions, class, about the calibration of the pipette? Actually, pag-calibrate sa burette ug sa volumetric flask, kani gihapon nga table ang gamiton. Ug kani gihapon nga formula. Ano lang sila, medyo naglahi lang sila sa way, sa way sa yung sa procedure and how to do the calibration. Kasi when we look at the burette, medyo mahaba ang procedure. Pero actually, ang procedure mahaba, pero ang solving and ang formula and ang table pareho lang. So paano sila nagkaiba? Ang pinaka taas lang og procedure sa calibration kay si burette. So you have to fill the burette, 'di ba? You have the burette. I-fill in lang to nimo with parehas lang temperature equilibrated na water, and then i-make sure lang nato na walay bubbles na na-trap dito sa tip sa atuang burette. And then i-allow lang nato siya about 1 minute for drainage, and then lower than the liquid level to bring the bottom of the meniscus to 0.00 ml mark. Okay? And then i-touch lang nato ang tip of the wall of a beaker to remove any adhering drop katong sa tip bitaw sa atuang burette, and then wait 10 minutes and recheck the volume. So if the stopcock is tight, kanang close jud siya totally, dapat wala na change dito sa meniscus sa liquid inside. Okay? Kaya diba i-fill in nato to ang atuang burette, and then maglampas mangyud-gud na sa zero mark ang na-fill in. So, ang una natong himuon is to make sure na naka-zero siya. Okay? So, during this interval, i-weigh nato to the nearest milligram ang atuang 125 ml conical flask fitted with a rubber. So, this is our actually receiver. Receiver gyapon ni siya, just like our pipette na i-weigh nato una ang atuang receiver. Now, once tightness of the stopcock has been established, mag-transfer ta from our burette approximately 10 ml of water dito sa flask na ato ang giweigh. And then, ano lang gihapon ni, touch the tip of the wall also sa flask para katong mga last drop maadto na siya dito sa flask. So wait 1 minute and then record the volume that was apparently delivered. So i-record na to, di ba? Ang ato ang i-deliver dapat 10 ml. And then i-refill na to ang burette. Dugangan na to siya sa water na equilibrated ang temperature. And then katong receiver class, i-weigh na sad nato. This time, the flask na and then the content. So, in the nearest milligram gihapon, ato ang gamiton. And just like sa computation sa pipette, makuha nato ang mass sa ato ang water na na-deliver just by getting the difference between the mass atong flask plus the content minus the weight of the flask, katong empty. And then we will convert the mass to the true volume using class kani gihapon na table and using the same formula. Okay? So mao lang na siya, subtract the apparent volume from the true volume. I'll give you an example later. So the difference is the correction that should be applied to the apparent volume to give the true volume. So repeat the calibration until agreement within plus 0.02 ml is, plus and minus 0.02 ml is achieved. And then uliton lang nato ato ang whole procedure sa calibration sa burette. Wait lang. Let me unshare. I'll give you an example on how to do this. I'll just need an empty slide for this. Okay. Ayan. So this is how you do naman the calibration for the burette. So supposedly, ang atuang volume na na-deliver, di ba, is 10 ml. So for example, the weight of the flask So for example, the weight of the flask is 29.315 milligrams lang sa atong gamitan ha. And then the weight of the flask plus the content is 39.450 milligrams. So ang atong unang buhaton class, I hope nasundan pa ha. You ask questions later pag dili masundan. Para makuha nato ang mass or ang weight of the water, isubtract lang nato ni. The content ha is the water. So isubtract lang nato na siya class 39.450 milligrams minus 29.315 milligrams. So this one is, wala sa tuy calcio. You can compute using your calculators there. You can do it ha, and then send lang sa chat. Okay. Ayan, 10.29.315 milligrams. Okay. Wait lang. Let me grams. Grams na lang grams. Ilisan na to ang unit para diretso. Okay, para dito mag-convert. Grams na lang. So this is in grams. Ayan. So mao ni siya ang weight sa water na ato ang na-compute. Now let's compute for the true volume using katong formula class na saan na to? Balikan na to ato ang slide. This one, weight of the water times volume at temperature. So weight of the water times the volume at temperature. So for example, this is done, kaning nga procedure, this is done at 25 degrees Celsius. So para ma-compute ang true volume, weight of the water is 10.135 grams times. We will look at the table. Remember the 25 degrees Celsius. Balik ta sa table. Ayan. And then let's have 25 here. Kaya mo ni siya ang temperature sa ato ang pag-weigh, 25 degrees Celsius. And then for example, 25 degrees Celsius gihapon ang water na ito ang gi-weigh. So we will be using this 1.0040. Okay? Tandaan ninyo 1.0040. 1.00 sobra. Duha lang deh. 1.0040 ml sa isa ka gram. So makancel ang grams, class. Mo man to yung unit ml per gram. And then you will get ml there. So 10.135 times 1.0040 is equal to 10.1755 ml. Meaning, mauni siya ang true volume na na-deliver sa burette. Okay? Again, mauni siya ang true volume. Kaning 10 ml, mauni siya ang apparent volume. Mao man gud ni ato ang na-read didto habang nagapa-flow ta sa water gikan sa burette. Pero kung i-correct nato siya with the temperature na needed, mao gyud ni ang tinuod na true volume. Okay, 10.1755 ml. And then, i-minus lang nato na to get the difference, na ay difference sa true volume, no? Ug ang ang apparent volume, i-minus lang nato na siya, class, para makuha nato ang difference. The true volume is 10.1755 ml minus the 10 ml, you will get there 0.1755 So accordingly, dili na ako i-erase ha, pero dili na to makita kung dili man gud na ako i-erase. So please take note, that the difference is 0.1755 Kay delete na ko siya, and then let's go back to the procedure. Okay, i-repeat daw nimo ang calibration until agreement within plus and minus 0.02 ml is achieved. Okay? Diba ang atong nakuha na difference is 0.1755 ml. Mag-repeat ka hangtod, class, nga ang difference na lang nila is plus most likely 0.02 ml. Balik na pug ka sa first na procedure, compute na sad ka ulit hangtod, class, makuha nimo ni nga difference. Pag makuha na nimo nga difference, that's the time calibrated na imuhang burette, pwede na siya gamiton for the experiment. So ano siya ha, dili siya actually, kung gusto jud ka nang tinud-anay nga analytical testing, and then measuring the volume, na exact volume gyud, before gid nimo siya gamiton, mo calibrate sa imuhang burette. And this is how you do it. Okay? Questions, class, about the calibration? Sige. So naka-record man ninyo, pwede ninyo siya ulit-uliton hangtod sa makuha ninyo siya. Anyway, I'm giving you, that is why I will not give a quiz right after the discussion, because I need you to study and I need you to look at the discussion again and again hangtod sa ma-absorb ninyo siya. Okay? Now, sa calibrating a volumetric flask, also the same thing. Parehas lang po og computation. Na-post na nako siya like kagain na. You can access the PPT sa inyuhang Schoology dito sa laboratory class na course. Okay? Para naamoy copy. Pati ang katong PPT yesterday na nasad siya dito para pag-abot sa exam, maka-answer pud mo og tama. Sige, calibrating a volumetric flask, that's the same thing. I-clean nato, i-dry ang flask, and i-weigh nato siya to the nearest milligram. And then i-fill nato to the mark. Diba, isa lang man ang graduation sa ato ang volumetric flask. I-fill nato siya and then i-transfer nato, i-weigh nato gihapon ang ato ang container and then i-check gihapon nato ang volume. So kung paano nato gihimo ang sa burette ug sa pipette, parehas lang ang sa volumetric flask. Pag makuha na nimo ang weight sa water, imuha na siyang i-check dinhi sa table. If ang temperature is 20 degrees Celsius, then you use this 1.0028 to correct the volume using this formula. So the volume delivered is equal to the weight of the water times the volume at P. Ang kanang volume at P, ano siya, temperature, for example, 20 degrees Celsius, ito ang kanyang volume at 20 degrees Celsius. 1.0028. Okay? So, maulan na siyang pag-compute para makorek ang volume na na-deliver or na-contain sa ato ang mga equipment, katong burette, pipette, and volumetric flask. Questions, class? Before ta mag-end.
Ma'am, all
Ginahimo ang calibration class before starting the experiment, before really using the apparatus for the experiment. So i-calibrate sa nato siya, kanang water ato ang ginagamit for calibration, di ba? Mag-measure ta og certain volume sa water, i-weigh nato ang water, and then i-correct nato ang volume until na makuha nato ng difference na 0.02 ml. Pag maabot na siya og 0.02 ml nga difference, meaning calibrated na ang imuhang apparatus and pwede na ka mag-proceed sa imuhang experiment or sa imuhang procedure. So pag pag ginagamit na nimo siya during the procedure, no need to correct na kay nakalibrate naman siya at the start. So again, I hope naklaro to siya nga ang calibration sa equipment ginahimo siya before the start of the experiment. Para ma-acclimatize lang ang imuhang pipette na mauni siya ang temperature nga gamiton for the experiment. Okay? Anything else? Hindi nakuhurutan akong time karon ha. It's 10:36. Our class is up to 12. So I'm giving you the remaining time. If you want to study, then pwede ninyo siya himuon. And then if you want to review the videos para sa mga na lesson nato, you can do that also as preparation sa exam next week sa lab. And then sa mga wala pa nahuman, basig na apay wala nahuman sa activities, you may utilize that time also. Kasi kung basig daghan mo ginahimo sa inyong mga other subjects, no? So you utilize my own time in doing the things na para sa ako ang subject para mahatag ninyo tanan ninyong kulang, and kung wala na mo'y kulang, you study na lang, ha? Kay next week, again, Tuesday, walay makalimot na exam na ta sa lab. And then after anang Tuesday class, ang sunod nga week kay exam week na baya sa lecture. So ang ako lang jung advice sa inyo ha, kay ayaw mo pag-cram. Basig ang ato ang exam kay sa Monday 22, basig mag-study mo sa 21. That is called cramming. You are just using your short-term memory. Dako ang tendency ana nga ma-mental block mo during the exam. Dili mo makaalala sa inyong gistudyhan. So ang jud better way to study is to study in advance para kung ang exam kay sa Monday, sa Sunday class naga-review na lang ka, dili ka nang naningkamot pag yung kag study. Okay? So ana atong buhaton ha, I'm giving you the remaining time to study and to do things para wala mo'y daghang habulon next time. Okay?